In this video we're going to figure out what the derivative is of hyperbolic cosine of x. Now let's just rewrite this in its exponential form. Let's just go ahead and use the chain rule to take the derivative of both of these exponential functions. So we're going to have e to the x multiplied by 1 plus e to the negative x multiplied by negative 1 all over 2, and that's going to be equal to e raised to x minus e raised to negative x all over 2. And remember, hyperbolic sine of x is equal to e raised to x minus e raised to minus x over 2. Therefore, the derivative of hyperbolic cosine of x is equal to hyperbolic sine of x. In this problem, we're going to figure out what the derivative is of hyperbolic sine of x. Now, let's just start by rewriting this in its exponential form. And we can rewrite this as, using the difference rule, now, in order to take the derivative of e raised to x, we'll need to use the chain rule. So the chain rule says we'll take the derivative of the outside part and we'll multiply that by the derivative of the inside part, which is just 1, minus, now let's just do the same here, e raised to minus x multiplied by the derivative of minus x is just minus 1 over 2, and that's going to be equal to e raised to x minus minus, so we have a positive here, e raised to minus x over 2. Now remember that we can rewrite hyperbolic cosine of x as this. Therefore, the derivative with respect to x of hyperbolic sine of x is equal to hyperbolic cosine of x. Hi, so in this video we're going to figure out what the derivative is of hyperbolic tangent of x. We can rewrite this as the derivative with respect to x of hyperbolic sine of x over hyperbolic cosine of x. Now at this point we're going to go ahead and take this derivative using the quotient rule. So we're going to have hyperbolic cosine of x multiplied by the derivative of the numerator, and that's just the exact same thing, minus hyperbolic sine of x multiplied by the derivative of the denominator, which is just the exact same thing again. And we're going to be dividing by hyperbolic cosine of x all squared. Let's just go ahead and simplify the numerator. So we're going to have hyperbolic cosine of x multiplied by hyperbolic cosine of x. So that's just hyperbolic cosine of x all squared minus hyperbolic sine of x all squared divided by hyperbolic cosine of x all squared. We can't really simplify the denominator, so let's go ahead and rewrite the numerator in its exponential form down here, and we'll see if we can simplify the numerator. So we're going to have e raised to x plus e raised to minus x over 2, and this is squared, so we're just going to multiply it by itself. Minus e raised to x minus e raised to minus x, multiplied by itself again because the hyperbolic sine of x is squared. This here is just the exponential representation of hyperbolic sine of x, and this here is just the representation of hyperbolic cosine of x. So notice we have a 2 and a 2 here in the denominator, and a 2 here and a 2 here in the denominator here. That means we can factor out a 1 over 4. It just makes multiplying everything out a little bit cleaner. So let's go ahead and multiply out everything in the brackets here. So we're going to have e raised to x multiplied by e raised to x, that's just e raised to 2x. Now we have e raised to x multiplied by e raised to minus x, that's just e raised to 0, and e raised to 0 is just 1. And then we have the exact same thing here. Then we have e raised to minus x multiplied by e raised to minus x, that's just e raised to minus 2x. Minus e raised to x multiplied by e raised to x, e raised to 2x, e raised to x multiplied by minus e raised to minus x, which is minus 1 again, and minus e raised to minus x multiplied by minus e raised to minus x is just positive e raised to minus 2x. At this point we want to go ahead and distribute this negative sign to everything inside these brackets here. So we're just going to have 1 over 4 multiplied by, everything here stays the same, Now we're just going to go ahead and simplify everything in the brackets. We have an e raised to 2x here and a minus e 2x here, so that's just 0. We have e raised to minus 2x here and a minus e raised to minus 2x here, that's just 0 again. We have 1 plus 1 plus 1 plus 1, which is just 4. 1 over 4 multiplied by 4 is just 1. That means that we can go ahead and rewrite hyperbolic cosine squared of x minus hyperbolic sine squared of x as 1. And that's just over hyperbolic cosine squared of x, which is just equal to hyperbolic secant squared of x. And that's the answer to this problem. In this problem we're going to solve the derivative of hyperbolic secant of x. Let's start by rewriting this as the derivative with respect to x of 1 over hyperbolic cosine of x. Now, in order to take the derivative of this, we can use something called the quotient rule. So let's just go ahead and do that. We would have, I'll just write out the formula for the quotient rule. G is the denominator of your fraction and f is the numerator. So we're going to have g multiplied by the derivative of f. The derivative of 1 is just 0, so we're just going to have 0 here, minus 1 multiplied by the derivative of hyperbolic cosine of x, which is just hyperbolic sine of x. And this is going to be divided by g squared, which is just hyperbolic cosine of x squared. And we can rewrite this as minus hyperbolic sine of x over hyperbolic cosine of x multiplied by 1 over hyperbolic cosine of x. And this is equal to minus hyperbolic tangent of x. And this is equal to hyperbolic secant of x. And that's the final answer to this problem. In this problem we're going to solve the derivative of hyperbolic cosecant of x. We're going to start by rewriting this as the derivative with respect to x of 1 over hyperbolic sine of x. At this point we're going to go ahead and use the quotient rule to compute this derivative. Just write the formula for the quotient rule here. g is just equal to the denominator of our fraction, and f is just equal to the numerator of our fraction. So we're going to have g multiplied by the derivative of f, which is just 0, minus 1 multiplied by the derivative of hyperbolic sine of x, which is just hyperbolic cosine of x, all over hyperbolic sine of x squared. Now we can rewrite this as minus hyperbolic cosine of x all over hyperbolic sine of x multiplied by 1 over hyperbolic sine of x. This is just equal to minus hyperbolic cotangent of x multiplied by hyperbolic cosecant of x. And that's the answer to our problem. For this problem, we're going to solve the derivative of hyperbolic cotangent of x. Let's start by rewriting this as the derivative of hyperbolic cosine of x divided by hyperbolic sine of x. In order to solve this derivative right here, we're going to have to use something called the quotient rule. You use the quotient rule whenever you want to take the derivative of something of this form. So let's go ahead and do that. So we're going to have, I'll just write it out first. This little prime sign here just indicates that we're taking the derivative of f. So we're going to have g equal to hyperbolic sine of x. Now the derivative of f is hyperbolic sine of x minus f, which is just hyperbolic cosine of x, multiplied by the derivative of g, which is just hyperbolic cosine of x. And this is going to be divided by g squared, which is just hyperbolic sine of x all squared. We can rewrite this as hyperbolic sine of x all squared minus hyperbolic cosine of x all squared divided by hyperbolic sine of x all squared. We can't really simplify the numerator. Let's go ahead and rewrite the numerator in its exponential form and see if we get a simpler expression. So we're going to have e raised to x minus e raised to minus x divided by 2 multiplied by the exact same thing minus e raised to x plus e raised to minus x multiplied by the exact same thing again. So this is just the exponential representation of hyperbolic cosine of x, and this is just the exponential representation of hyperbolic sine of x. Notice we have a 2 times 2 here and a 2 times 2 here, so we can factor out a 1 over 4. And we're just left with e raised to x minus e raised to minus x multiplied by itself minus e raised to x plus e raised to minus x multiplied by itself again. So we're just going to go ahead and multiply out everything in these brackets here. We're going to have 1 over 4 multiplied by, now e raised to x multiplied by e raised to x is just e raised to 2x. E raised to x multiplied by minus e raised to minus x is just minus 1. And we're just going to have another minus 1 here. Minus e raised to minus x multiplied by minus e raised to minus x is just positive e raised to minus 2x. Now we're just going to have e raised to 2x here, plus 1 again, plus e raised to minus 2x. So we're just going to go ahead and distribute this minus sign to everything inside the brackets there. We're going to have 1 over 4 multiplied by e raised to 2x minus 2 plus e raised to minus 2x minus e raised to minus 2x minus 2 minus e raised to minus 2x. So we have an e raised to 2x here and a minus e raised to 2x here. So that's just 0. And we have an e raised to minus 2x and a minus e raised to minus 2x here. So that's just 0. And minus 2 and minus 2 is minus 4. Minus 4 multiplied by 1 over 4 is just minus 1. Therefore, hyperbolic sine squared of x minus hyperbolic cosine squared of x is equal to minus 1. Got the minus sign here. And that means that we can rewrite this up here as minus 1 all over hyperbolic sine squared of x. That is equal to minus hyperbolic cosecant squared of x. And that's the answer to our problem.